One of the most popular versions of the teleological argument today goes by the name of the fine-tuning argument. Beginning in the 1950s, physicists have discovered that many of the fundamental features of the universe seem to have been delicately adjusted and exquisitely balanced to allow for the possibility of our existence. As it turns out, life in the universe exists on a razor's edge. Alter any number of the basic properties of our physical universe by even the slightest value, and our universe would be completely sterile and devoid of life. It would be life-prohibiting rather than life-permitting. This remarkable and surprising discovery is referred to as the fine-tuning of the universe. Now, it's important to understand that the term fine-tuning does not mean designed. Fine-tuning is not an idea cooked up by religious believers. The term was coined by physicists, and the idea is explored in physics journals. Fine-tuning, as it's used among physicists, is actually a neutral term that simply refers to the discovery that many of the fundamental properties and features of the universe fall within extraordinarily narrow and incomprehensibly improbable ranges that are required for the existence of complex chemistry and of life of any kind. Fine-tuning is today a broadly accepted and uncontroversial fact of physics. It's not a religious idea. And as I say, this fact about the universe is both remarkable and surprising. After all, countless students in the developed world throughout the modern and contemporary eras have been taught that our existence in the universe is decidedly unremarkable and unsurprising. A common narrative or myth told and retold over the last several hundred years is that although there was a time when mankind thought that there was something special about our existence in the cosmos, the age of reason and science disabused us of this belief, a belief that we now know to be the result of wishful thinking and superstition. But the irony of ironies is that the very science that was supposed to have freed us from the delusion of our own uniqueness has now revealed to us just how fantastically rare, just how unimaginably improbable, just how special our existence in the universe truly is. We now know that ours is a Goldilocks universe. Our universe is one that is just right for life. Of the near infinite range of life-prohibiting values that the fundamental features and properties of the universe could have taken, the actual values that they have in our universe just happen to be among the exceedingly rare ones that are necessary for us to be here. Physicists have uncovered many instances of fine-tuning at the fundamental layer of the physical universe. We can organize the instances of fine-tuning into three general types. The first kind of fine-tuning has to do with the basic stuff of the universe. For some time now, we've known that all physical things are made of subatomic particles that form the building blocks of the universe. In order for there to be complex chemistry, which is the basis for the existence of any kind of life, certain features of these fundamental particles, such as the masses of the electron, the up quark, and the down quark, must be precisely dialed in. The second kind of fine-tuning has to do with the constants of the universe. And by constants, I mean the unchanging values of the physical forces in nature, such as the fundamental forces of gravity, electromagnetism, and the subatomic strong and weak force, as well as that mysterious force that we call dark energy. Again, for any kind of life to exist, the strengths of the various forces in nature and the ratios between them must fall into an exceedingly narrow life-permitting range. The third kind of fine-tuning has to do with the initial conditions of the universe. By initial conditions, physicists mean the initial arrangement and distribution of the matter and energy given in the Big Bang. Against incomprehensible odds, we live in a universe that had initial conditions just right for the formation of life. Now, a helpful way to grasp the fine-tuning of the universe is to imagine a universe-making machine. Imagine that on the control board of this universe-making machine, you had multiple dials, each representing a cosmological fine-tuning parameter. So, for example, one dial would represent the strength of the strong nuclear force, another, the expansion rate of the universe. Then there would be a dial for each of the masses of the up quark, the down quark, and the electron. There'd be a dial for the gravitational force constant, the initial entropy, and so on. Each one of these dials would have an unimaginably vast number of possible settings. However, in order to generate a universe that was life-permitting, each dial would have to be set to a narrowly precise value, and the slightest tick of any one of the dials in the wrong direction causes the universe to become sterile and lifeless. Now, it's crucial to see that the various finely tuned constants and quantities that we find in the universe, represented by the dials in our universe-making machine, are not determined by the laws of nature. In other words, if we want to know what the value is of, for example, the strength of the gravitational constant, we can't just do a calculation. We have to go out and measure it. The laws need to be told what the values of various constants, quantities, and initial conditions are. The laws need to be told, for example, of what the mass of the electron is, or how strong the weak nuclear force is, or how much matter there is in the universe. The laws of nature are consistent with the values of these constants and quantities being different than they are. It's absolutely astounding, then, that the values we find for the various constants and quantities in nature just happen to be the exact ones that are needed for life. Now, what this illustration fails to capture is the utter vastness of the parameter space for each of these finely tuned variables. The range of possible settings that each one of these dials in our illustration can have are incomprehensibly large. The numbers that are involved here are so massive that they can only be truly appreciated by physicists and mathematicians. And I actually think that the full force of fine-tuning is missed by non-physicists like me, who struggle to comprehend the value of the exponential figures involved. The best way to see this is to look at some specific examples of fine-tuning from each of the categories that we reviewed above. Physicists have discovered that a life-permitting universe requires that the mass of the up quark be fine-tuned to roughly 1 part in 10 to the 21st power. Now, written out, this number is a 1 that's followed by 21 zeros, an incomprehensibly large number. To give some context here, the number of seconds that have ticked away since the beginning of the universe nearly 14 billion years ago is just 10 to the 17th power. Or consider the cosmological constant, that mysterious force that is driving the accelerated expansion of the universe and which physicists call dark energy. Physicists agree that the degree of fine-tuning for the cosmological constant is no less than 1 part in 10 to the 90th power. Now, many place the number as high as 1 part in 10 to the 120th power. Again, written out, that number is a 1 with 90 zeros behind it. To help you appreciate the size of this number, it's estimated that the total number of protons in the universe is 10 to the 80th power. Now, imagine that we specifically marked at random just one of these protons somewhere in the universe, and then blindfolded you and gave you the ability to pick any single proton anywhere in the universe. The probability of your finding the specifically marked proton at random is 10 billion times better than that of the probability that the cosmological constant would just happen to have a value that would make the universe life-permitting. This level of fine-tuning is staggering. But even this is nothing compared to the fine-tuning on display in the initial low-entropy arrangement of matter and energy with which the universe began. Our universe began in an extraordinarily rare, highly ordered state with a plenitude of useful or free energy. The Oxford theoretical physicist Roger Penrose has calculated that the odds of getting low-entropy, life-permitting initial conditions by chance alone from among the range of possible initial conditions is on the order of 1 part in 10 to the power of 10 to the power of 123. That's 10 raised to the 10th power, or 10 billion, raised again to the 123rd power, a number that is so large it is literally incomprehensible. This figure is so exceedingly large that if I could write it out, there would end up being far more zeros in this number than there are elementary particles in the universe. In fact, we'd need 10 to the 43rd power more universes to have enough particles to match the number of zeros in this number. There is simply no way to adequately communicate the degree of fine-tuning that this represents. Now, I think that the fine-tuning of the universe has clear theistic implications. It just seems like a setup job. It seems as if the parameters of the universe were deliberately dialed in for our existence. It seems, that is, like our universe has been designed for life. And the teleological implications of fine-tuning have not been lost on physicists. The late British astrophysicist Sir Fred Hoyle, who was among the first to discover evidence of fine-tuning in the 1950s, put it plainly when in 1981 he wrote, quote, "A common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me to be so overwhelming as to put this conclusion almost beyond question," unquote. Likewise, contemporary physicist and expert on cosmic fine-tuning Paul Davies has written, quote, "There is for me powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming," end quote. And finally, the late Stephen Hawking, quote, "The remarkable fact is that the value of these numbers seem to have been very finely adjusted to make possible the development of life," end quote. Now, as I've said, fine-tuning is a well-established fact of physics, and it has been for some time now, again, at least since the 1950s. This, however, has not stopped some critics from attempting to dismiss or explain it away. There are a lot of responses to fine-tuning going around, especially on the internet, that are just, well, stupid. But they're so prevalent that we need to say something about them. So let's briefly look at a sampling of these unserious attempts to explain away fine-tuning. One of the most common reactions to fine-tuning is that future science will figure it out. We just need to give science time. With enough time, science will fully explain fine-tuning. Well, maybe. Maybe it will, and maybe it won't. Who can tell what future science is going to say? Who's to say that the fine-tuning mystery won't further deepen with the advance of science? I mean, after all, this has been the trend. The more we've come to know about the universe and about life, the stronger the case of fine-tuning has become. There's simply no reason to think that this trend is going to reverse with the advance of science. But regardless of this, what we can confidently say is that right now, the universe looks to have been exquisitely fine-tuned for life. Now, sometimes in response to fine-tuning, you'll hear it claim that we've only observed one universe. So the probability of our universe supporting life is 1 out of 1, or 100%. It's therefore meaningless to talk about probabilities when it comes to the universe, since we have only one instance. But this response to fine-tuning is just really, really bad, and it totally misunderstands the fine-tuning problem. Fine-tuning has nothing to do with how many universes we observe. Obviously, we only observe one, but rather how many different ways our universe could have turned out, given the laws of nature. Here's an illustration from physicist John Barrow to help us see what's going on here. Let's say that a blue dot represents a life-permitting universe and that a red dot represents a life-prohibiting universe. Now, if we were to take a blank piece of paper and mark every change to one of the fundamental constants, quantities, and initial conditions of the universe with a dot representing a new possible universe, what we would end up with is a vast sea of red dots representing life-prohibiting universes, and only a handful of blue dots representing life-permitting universes. This is the sense in which a life-permitting universe is improbable. Now, sometimes it's objected that we need to consider universes with different laws of nature. Maybe universes with different laws of nature are more life-friendly. But again, this just misunderstands the nature of fine-tuning. Considering the possibility of different laws of nature does nothing whatever to address the fine-tuning problem. In fact, it's totally irrelevant. Again, the problem is this. Among the vast array of possible universes governed by our laws of nature, the chance of randomly getting a universe like ours with a life-permitting mix of constants, quantities, and initial conditions is virtually zero. Remember that our laws of nature do not determine the values of the constants, quantities, and initial conditions of the universe. They could have been different than they are. Okay, so maybe considering the possibility of different laws of nature doesn't blunt the fine-tuning problem, but what about considering other forms of life? Perhaps there could be non-carbon-based life forms that could survive in universes in which carbon-based life, like us, cannot. However, it's important to see that fine-tuning is not just necessary for a universe containing carbon-based life, but it's also necessary for a universe containing matter and chemistry. When physicists talk about a universe fit for life, they mean a universe that can support any organism, no matter what its chemical composition, that can fulfill the basic requirements of life, which consist in the ability to take in nutrients and convert them into energy for growth and adaptation and reproduction. But a universe without stable matter and chemistry could not support life of any kind, no matter how basic. All right, let's look at one more unserious but very common response to fine-tuning that is related to what's known as the anthropic principle. It's often stated, again, especially on the internet, that we don't need an explanation for why we observe a universe that supports life, because a universe that supports life is the only kind of universe that we could possibly observe. So there's nothing to see here. Move along. Well, I hope you can see that this reasoning is just fallacious. The fact that we could only observe a life-permitting universe does nothing to explain why, against all odds, our universe is life-permitting rather than life-prohibiting. Obviously, observers must inhabit a universe that permits observers. But the question still remains, why does a life-permitting universe exist rather than a vastly more probable life-prohibiting universe? Now, as philosopher William Lane Craig points out, when it comes to explaining the fine-tuning of the universe for life, there are really only three live options. The fine-tuning of the universe is either due to necessity, chance, or design. Let's briefly consider the first of these two options, that of necessity. Some propose that the universe has to be life-permitting, that is, that the constants, quantities, and initial conditions must have the values that they have. So according to this view, a life-prohibiting universe is physically impossible. Of course, the problem with saying that the conditions of our universe are physically necessary is that it just seems obviously wrong. As we've seen, the constants, quantities, and initial conditions are not determined by the laws of nature. So why think that they could not have turned out different than they are? It just seems evident that the up quark could have had a mass slightly greater or slightly lesser than it does, or that the strength of the electromagnetic force could have been slightly more powerful or slightly less powerful than it is. Features like these are clearly contingent. They could have been otherwise. And if someone wants to argue that they are necessary, that person needs to provide us with some proof of their necessity. But it doesn't seem like there could possibly be any such proof. Now, a more sophisticated and scientifically informed version of the necessity explanation for fine-tuning will appeal to the possibility that there is some not yet discovered deeper law or deeper physics that, when discovered, will explain why the constants, quantities, and initial conditions of the universe must be the way that they are, why they could not possibly be different. This was Albert Einstein's dream, that we would find some theory of everything that would completely determine the values of the constants of nature. However, even if such a theory exists, and that's a big if, there is no reason at all to think that it would do anything to resolve the mystery of fine-tuning. At best, it would merely relocate the problem back a step. As the Australian physicists Garrett Lewis and Luke Barnes point out, quote, even if Einstein's dream were true, it wouldn't show that the universe couldn't have been otherwise. It only shows that the constants are determined within that particular deeper theory. We would still want to know why the universe obeyed that deeper theory. Even if there are no alternatives within the deeper theory, there are alternatives to the deeper theory. If Einstein's dream were true, instead of writing books about the fine-tuning of the constants of nature, we'd write books about the laws of nature themselves. Instead of alternate values of constants within a theory, we discuss alternative theories, but all the same fine-tuning problems would arise, end quote. So it doesn't seem like we're going to be able to give a satisfying explanation for fine-tuning by appealing to physical necessity. But what about chance? Why can't we say that we just got really, really, really lucky? Well, the main problem with appealing to chance as an explanation for the fine-tuning of the universe is that the probability of getting a life-permitting universe at random is so stupendously low that it makes this option unreasonable for anyone who truly appreciates the numbers involved. Or, as we saw Fred Hoyle put it, the numbers that one calculates from the facts are overwhelming. Now, in reply to this, it's sometimes argued that highly improbable events happen all the time. Your existence, for example, is an incredibly improbable event, yet here you are. Consider a lottery. Although it's extremely improbable that any one ticket holder should win, it's certain that some ticket holder will win. Somebody has to win, and whoever wins will win purely by chance. Likewise, it's argued that although all the universes within a range of possibilities are equally improbable, we shouldn't be surprised that one of them wins and wins purely by chance. But this response is just confused. Again, as we've seen already, the problem of fine-tuning is not that the existence of this particular universe is improbable. The problem is that this universe is life-permitting when it is overwhelmingly more probable that it be life-prohibiting. To help illustrate this point, William Lane Craig revises the lottery analogy to accurately illustrate the fine-tuning problem. Imagine a lottery in which one black ping pong ball is dropped into a cosmic-sized lottery ball machine where it's randomly mixed together with billions upon billions upon billions of white ping pong balls. Now, the odds of randomly selecting any particular ball are equally improbable. However, and this is the crucial point, whichever ball is selected, it is fantastically more probable that the ball selected will be white and not black. As Craig explains, quote, getting the black ball is no more improbable than getting any particular white ball, but it is incomprehensibly more probable that you'll get a white ball instead of a black one. So if the black ball rolls down the chute, you certainly should suspect that the lottery was rigged. In the same way, some universe has to exist, but whichever universe exists, it is incomprehensibly more probable that it will be life-prohibiting rather than life-permitting, end quote. The only way to make the chance explanation for the fine-tuning of the universe reasonable is to try to improve the odds. And by far, the most popular attempt to do this today is by appealing to the existence of the multiverse. That is to suggest that our universe is just one in a vast universe ensemble. If there are an infinite or near infinite array of actually existing universes, each with randomly chosen values for their constants, quantities, and initial conditions, then we should expect a life-permitting universe to appear somewhere in this universe ensemble. To go back to the lottery analogy, if all the balls eventually roll down the lottery chute, the black ball is bound to roll down the chute at some point. And since only universes that are fine-tuned will have observers in them, we shouldn't be surprised to find that our universe is fine-tuned for life. So what can we say about the multiverse explanation of fine-tuning? Well, not much, actually, because at this point, it's little more than pure speculation. There's no direct evidence for the multiverse. It can't be detected, and there's probably no way in principle to confirm its existence. Moreover, there isn't anything like a standard theory of the multiverse out there, so there's really nothing of substance to respond to. For the multiverse to be taken seriously as a plausible explanation of fine-tuning, it has to be more than just a bare possibility. And just positing the existence of the multiverse does not even begin to address fine-tuning, since not any old multiverse will do. For one thing, the multiverse has to be sufficiently vast if it's going to beat the odds and ensure the existence of a life-permitting universe. For another thing, the universes within the multiverse have to be sufficiently varied. They have to exhibit a wide range of variation in their constants, quantities, and initial conditions. So, in order to overcome the overwhelming odds against getting a finely tuned universe by chance, the multiverse must be both vast and varied. You have to have enough universes in your multiverse, and they must be sufficiently different from one another. And this leads to another problem facing the multiverse explanation. If the multiverse is going to be a plausible solution for the fine-tuning problem, we'll need to postulate the existence of some kind of randomizing mechanism or element responsible for both the number and variation of universes, a kind of cosmic slot machine or cosmic roulette wheel. But now it looks like the specific features of this universe generator itself will have to be finely tuned. Far from solving the fine-tuning problem then, the multiverse solution may simply relocate the fine-tuning problem to a deeper level. In effect, we'll be trying to explain the fine-tuning of our universe by appealing to prior and unexplained fine-tuning at the level of the universe generator. And if this were not bad enough, any multiverse explanation that posits the existence of a sufficiently vast and random number of universes faces what looks to be a devastating objection. It goes by the ominous name, the invasion of the Boltzmann brains, named after the Austrian physicist and mathematician Ludwig Boltzmann. The basic argument is this: since getting small regions of order by chance alone is vastly more probable than getting large regions of order by chance alone, if the multiverse really exists, we should be observing a very small region of order in an otherwise chaotic soup of a universe. But we don't. Instead, we live in a universe that appears ordered through and through, and in every direction that we look. The eminent physicist Roger Penrose has recently calculated and compared the odds of randomly getting a universe with the precise initial low entropy state that ours has, and randomly getting a universe no larger than our local solar system that has been formed by the random collision of particles. Penrose found that a universe no larger than our solar system formed by a random collision of particles is unfathomably and stupendously more likely than getting an ordered universe as large as ours. Thus, it is exceedingly more likely that we should be observing an ordered universe no larger than our solar system, rather than the universe that we actually observe. But it gets worse, because if we carry this logic to the extreme, it turns out that a small ordered universe in which a single brain randomly fluctuates into existence with the illusion that it inhabits a massive ordered universe is exceedingly more probable than a real universe like ours that is finely tuned. So if the multiverse exists, by far the most probable universe will be one in which a solitary brain randomly fluctuates into existence and has illusory perceptions of an ordered universe. But then it seems that if the multiverse is indeed real, then you are rationally committed to the belief that you are, in fact, that solitary brain inhabiting the universe, and that everything that you perceive around you is just an illusion. Needless to say, if your theory predicts that you are overwhelmingly likely to be a Boltzmann brain, your theory's in trouble. It is highly doubtful, then, that appeal to the existence of a multiverse can do anything to alleviate the fine-tuning problem. And since the multiverse seems to be the only way to salvage chance as an explanation for fine-tuning, it looks like chance is off the table. as a plausible option. But if physical necessity fails as an explanation for fine-tuning, and chance fails as an explanation for fine-tuning, we seem to be left with but one option. Fine-tuning is the result of design. Now, formulated deductively, the argument goes like this. 1. The fine-tuning of the universe is due to either physical necessity, chance, or design. 2. It is not due to physical necessity or chance. Therefore, 3. It is due to design.